Chemistry powers today, but courageous chemistry is shaping our tomorrow. It's fueling the hydrogen economy and driving clean energy. It's in our semiconductors and even powers our 5G. It makes bridges stronger and medical equipment safer. Chemistry powers progress and binds us all together. But there's something more that sets us apart. Courageous chemistry.
Hello and welcome to today's lesson. In today's lesson we'll look at a branch of physical chemistry known as electrolysis. In this lesson we'll look at what electrolysis is and the terms associated with electrolysis. Now when you hear the word electrolysis, we are talking about using electricity, or basically called current, to split a compound or decompose a compound into maybe constituent element or smaller compound, as the case may be. Okay, now this compound must be in what we call the molten state or aqueous state. That is, electrolysis does not occur when the compound, or what we call the electrolyte, which we will learn shortly, is solid. It must be molten and must be what? Aqueous. Take note of that. So the first thing we're looking at today is an electrolyte. Like I said, an electrolyte is a compound which of course will be molten or aqueous that conducts electricity. That is, it conducts electricity. Electron can flow through it. This conduction is what results in the breaking down or decomposition of the electrolyte. Okay, now electrolyte can be classified as molten and aqueous electrolyte. The molten electrolyte does not contain water. It is a substance that is melted, like sodium chloride, that can be melted up to about 800 degrees plus. Okay, this one does not contain water, but the aqueous electrolyte contains water, which can later split into hydroxide and hydrogen. Do you get it now? Yes. So know the difference between molten electrolyte and aqueous electrolyte. What is an electrode? An electrode is a piece of rod through which electricity enters and leaves the electrolyte. Okay, it is this electrode that the reactions occur. Okay, electrode is classified as inert electrode and active electrode. Now the inert electrode do not react with the electrolyte. Okay, and there are basically three inert electrode. Number one, we have carbon, we have graphite, and then we have platinum electrode. Okay, on the other hand, active electrode, they do react to the electrolyte. That is, there is free flow of electron or interaction between the electrolyte and the electrodes. And beside this, all other electrodes like your copper electrodes, the zinc electrodes, they all belong to this category of active electrodes. Okay, it is important to note here that electrolysis occur in an electrolytic cell. In an electrolytic cell, it is the setup where you have the electrolytes, the electrodes, the battery, which of course is going to pass the direct current, okay, to cause the decomposition process to occur. While electrolysis is just simply the process in which the whole concept work, that is, the decomposition takes place. Now the electrodes are categorized into two. One is called the anode, the other one is called the cathode. In an electrolytic cell, the anode is the positive electrode to which the positive terminal of the battery is connected to, and the cathode is the negative electrode to which the negative terminal of the battery is connected to. Now during electrolysis, positive ions will flow to the cathode while negative ions will flow to the anode, simply because opposite charges do attract. So for note taking, you can see the anode is the positive electrode connected to the positive terminal of the direct current power source. And oxidation, that is, the loss of electron, occurs at the anode. On the other hand, the cathode is the negative electrode connected to the negative terminal of the direct current power source. where reduction or gain of electron takes place. In an electrolyte, during electrolysis, ions are formed, okay, and anions are usually those that carries negative charge, so they will flow to the positive terminal, which of course is the what? Anode, is it not? While cations are those that carry positive charge, and then they will flow to the negative terminal, which is called the what? Cathode. Okay, so by definition we can come to an understanding that electrolysis is the chemical decomposition of an ionic compound by passing what? Electricity through the what? Molten or aqueous solution of the what? Compound, is it not? Yes. In other words, electricity is required for this electrolysis to occur, meaning it is a non-spontaneous what? Reaction. Take note of that.
Not all liquids can conduct. The liquid can be a molten ionic compound or an aqueous solution. In either case, it must be able to carry current. Let's take a common example, table salt. If you heat sodium chloride to over 801 degrees Celsius, it will melt. The liquid will contain free-flowing positive sodium ions and negative chloride ions. This simply means that sodium and chloride ions are free to move within the liquid sodium chloride. Positive ions are called cations. Negative ions are called anions. Now consider putting two electrical conductors into the liquid. Copper would be good as it has a higher melting point. Nothing happens to the ions at this point, but if we connect the two bits of copper to an electrical cell or power supply, then things start to get interesting. We do need to sidestep for a moment to look at electrical current in a metal. Electrons in a metal aren't bound to particular atoms. They form a sea of electrons that can move easily if a potential difference or a voltage is applied across it. This could be from an electrical cell or a battery. The electrons will begin to drift towards the positive terminal of the battery, and this is what happens when current flows. Current is the movement of charge, in this case electrons. Now, let's go back to our molten sodium chloride. We've added our copper wires, let's call them electrodes, and now we'll connect these to an electrical cell. The electrons will start to flow in the wires, and this will cause one electrode to become positively charged and the other negatively charged. This has an immediate knock-on effect in the molten sodium chloride, which you'll remember is a mixture of sodium cations and chloride anions. Anything positively charged in the liquid, in this case the sodium ions, is going to be attracted to the negative electrode. And anything negatively charged, in this case the chloride ions, is going to be attracted to the positive electrode. This is because opposite electrical charges attract. When the ions meet the electrodes, electron exchange happens, and this triggers a chemical reaction. Solids can form, gases can be given off, and new solutions can be left behind. It all depends on the liquid and what material the electrodes are made from. For the electrodes, which are usually metal plates with a larger surface area than a piece of wire. The positive electrode is called the anode, it attracts anions, and the negative electrode is called the cathode, it attracts cations. The liquid is effectively conducting electrical current. The only difference is that the charge carriers in the liquid, in other words the charged particles that are moving, are ions. If a liquid has free moving ions and can conduct like this, it is called an electrolyte. Remember that electrolysis can also take place in ionic solutions as well as molten compounds. The more concentrated that solution, the greater the ion flow rate. Ion flow rate can also be increased by increasing the potential difference or voltage across the cell. Electrolysis is the flow of electrical current in a conducting solution or molten liquid that causes chemical changes. The conducting liquid is called an electrolyte and has free moving ions. The conducting plates, bars or wires inserted into an electrolyte are called electrodes. Positive ions are called cations and are attracted to the cathode. Negative ions are called anions and are attracted to the anode. When current flows in an electrolyte, it is the ions that move and carry the electrical charge. When current flows in the electrodes and wires, it is the electrons that move and carry the electrical charge.
Welcome back. That time brings us to the end of today's lesson. I hope you've learned something. Test your ability by attempting the quiz. See you in next class.